Good day, dear viewers. I am Analyn Malines, a faculty member of the Mathematics Department from the College of Natural Sciences and Mathematics of the Mindanao State University main campus, Marawi City. I am one of the video lecturers to discuss the topics in Chapter 5, Elementary Statistics, for the course GEC104 Mathematics in the Modern World. In addition to measures of central tendency and measures of variation, in this video lecture, I am going to discuss the different measures of relative position. In general, the significance of one observed value in a data set often depends on how that value compares to the other values in that data set. For example, when you take an exam, what is often as important as your actual score on the exam is the way your score compares to other students' scores. If you made a score of 70 in a 100-item exam, but the average score was 85, you did relatively poorly in the exam. If you made a score of 70, but the average score was only 55, then you did relatively well. These measures of relative position are also known as fractiles. Also, on this video lecture, I'm only considering measures of relative position of ungrouped data. And when we say ungrouped data, these are data you first gather from an experiment or study. The data are raw, that is, it's not sorted into categories or presented in a frequency distribution table. Otherwise, you have group data. These measures of relative position include percentile, decile, quartile, and ZScore. So let's start with percentile. The percentiles are values that divide a set of observations arranged increasingly into 100 equal parts. Percentile is denoted by P sub k. K ranges from 1 up to 99. The kth percentile is interpreted as the value such that k% of the observation falls below it. For illustration, if we have the first percentile, then it is the value such that 1% of the observation falls below. So when we say falls below, less than that value. When we have the second percentile, it is the value such that 2% of the observation falls below that value. Same goes with the third percentile. It is the value such that 3% of the observation falls below that value, and so on and so forth up to the 99th percentile. It is the value such that 99% of the observation falls below that value. So in finding the percentile, the kth percentile in a data set, we are going to follow these steps. So the first step is we arrange the data in increasing order of magnitude. Second step is we find the location of the kth percentile by computing L is equal to NK divided by 100, where N is the number of observations, K is the unknown percentile, and once you compute for L, there are two possible results. The first case is L is an integer. So when L is an integer, then the desired value is the average of the L and L plus 1 observations. And the second case, if L is not an integer, you round up L to the next higher integer. The desired value is the observation located to the rounded up value of L. To apply the given steps, let's consider examples. So for the first example, the following table lists the calories per 100 ml of 10 popular sodas. So we are given with the calories of selected sodas. So we have 10 popular sodas. So find the first, we have the 48th percentile. And the second, find the 70th percentile. For our solution, in finding the 48th percentile, first, we need to arrange the data in increasing order. That is, from the given data, the lowest is 26, followed by 37, 39, 41, 43, and so on. And the highest value is 56. Step 2 is we compute for the location or determine the location of the 48th percentile by using the formula n times k divided by 100. In this given example, our n is 10. We have 10 popular sodas. Our k is the unknown percentile, so we have 48 divided by 100. So we have 480 divided by 100 gives us 4.8. So our computed value for L is not an integer, which is 4.8. So we round it up to the next higher integer, which is 5. L stands for location. Therefore, the 48th percentile is the 5th observation in the arranged data set. So, yung naka-arrange, doon tayo titingin ng 5th observation. So, from the arranged data, so we have 43 as the 5th observation. So, 26 the first, 37 the second, 39 third, 41, then 43 is the 5th observation. Therefore, we can conclude that 48% of the observation falls below 43. For letter B, finding the 70th percentile, same steps. So we arrange the data in increasing order. So we have this arrangement. Second, we compute for L. So we have NK divided by 100 to find the location of the 70th percentile. Our N is 10. We have the 10 sodas. In this example, K now is 70 and divided by 100. So we have 7 as computed value for L. So in this case, the computed L is equal to 7, which is an integer. So yung mangyayari ngayon is we get the average of the L and the L plus 1 observation. So we add the two values, then divide it by 2. So the 7th observation plus the 8th observation divided by 2. So refer to the arranged data. So the 7th observation is 45. And the 8th observation is 48. Get the average. So we have 93 divided by 2, so we have 46.5. Therefore, the 70th percentile is equal to 46.5. Thus, 70% of the observation of the values are less than 46.5. So that's percentile. Now, let's proceed with decile. Deciles are values that divides set of observations when arranged increasingly into 10 equal parts. Decile is denoted by d sub k. K ranges from 1 to 9, and kth decile is interpreted as the value such that 10 times k% of the observations falls below it. Note, now for percentile, it is k% for us to interpret. But in this case, for decile, we need to multiply k by 10. So, for example, we have d sub 1, or the first decile, it is 10% of the values falls below d sub 1. When we say d sub 2, 20% of the values falls below d sub 2. And d sub 3 and so on up to d sub 9, it means 90% of the values falls below d sub 9. So for the steps in computing the kth decile, so we arrange the data, same lang kanina for percentile, in increasing order of magnitude. Then second, we now find the location of the kth decile by computing L is equal to nk divided by 10. So now the denominator becomes 10 because deciles divide the distribution into 10 equal parts, where n is the number of observations. Then same as percentile, we are going to consider two cases after we compute for L. If it is an integer, then we get the average of the L and the L plus 1 observation. If it is not an integer, then we round up L to the next integer. The desired value is the observation located to the rounded up value of L. So for our example, so using the data from the previous example on 10 popular sodas, so we have the calories per 100 milliliters. So we find the third decile. So step 1, in finding the third decile, we arrange the data in increasing order. So we have this arrangement: 26, 37, 39, 41, 43, 45, 45, 48, 53, and 56. Second step is we find the location of the third decile by computing L. Note that the formula for L for decile is nk divided by 10. So our n, the number of observation, is 10. Our k, we are looking for the third decile. So 3 divided by 10. So we have 30 divided by 3. So the result is 3. So we have a whole number, or we have an integer value for L. So in this case, we get the average of the third and the fourth observation in the arranged data. So the third observation is 39 and the fourth observation is 41. We get the average. So we have 80 divided by 2. So we have 40. Thus, the third decile is equal to 40, interpreted as 30%, 3 times 10%. So we have 30% of the observation falls below 40. another example. So we have example number 3. The following are the ages of customers who purchase a cruise. So we have these values: 32, 61, 46, 51, 45, 55, 23, 44, 33, 47, and 51. We need to find the 8th decile. So for our solution, we follow the steps. Step 1, we arrange the data in increasing order of magnitude. So we have the lowest value, 23, followed by 32, 33, and so on. And the last value, the highest value is 61. All in all, we have 11 observations. Next, we compute for L. So find the location of the 8th decile by computing L is equal to NK divided by 10. Again, the number of observations is 11 times 8 divided by 10. So we have 88 divided by 10, which is equal to 8.8. Thus, our L is not an integer. So we round it up to the next higher integer, which is 9. Therefore, the 8th decile is the 9th observation in the arranged data. So we have 51. So we have 51 as the 9th observation. So 9th observation is 51. Therefore, we can say that 80%, since it is 8 times 10%, so we have 80% of the observations falls below 51. Now, let's proceed with quartile. So quartile or quartiles are values that divide a set of observations arranged increasingly into 4 equal parts. Quartile is denoted by Q sub k. K ranges from 1 up to 3. So, kth quartile is the value such that 25 times k% of the observation falls below it. So, for percentile, k%, for decile, 10 times k%. Now, for quartile, we have 25 times k%. So, for our illustration, so we have this. So, note that we have 4 division kasi 4 equal parts, at 25% each part, and we have Q from 1 to 3. So, this is considered as our first quartile. Thus, if we have Q sub 1, it is 25% of the values falls below the first quartile. If you have the second quartile, meaning 50% of the values falls below the second quartile. And for the third quartile, it means 75% of the values falls below the third quartile. For the steps in computing the kth quartile, so step 1, same as percentile and decile, we arrange the data in increasing order of magnitude. Second, we find the location of the kth quartile by computing L is equal to NK divided by 4. So if you observe, the denominator is the number of division. So for percentile, over 100. For decile, over 10. For quartile, over 4. Where N is the number of observations. So, same as decile and percentile, for the values of L, if L is an integer, then the desired value will be the average of the L and L plus 1 observation. And for the second case, if not an integer, we round up L to the next integer. The desired value is the observation located to the rounded up value of L. So for our example, find the third quartile for the test scores 28, 5, 18, 7, 22, 11, and 6. So for the solution, so step 1, we need to arrange the data in increasing order of magnitude. That is, we have now the arrangement 5, 6, 7, 11, 18, 22, and 28. Thus, we have 7 observations. Our N is 7. Second step is we compute for, or we determine the location of the third quartile by computing L. So L is equal to NK divided by 4. N is 7 multiplied by the unknown quartile, which is third quartile divided by 4. So we have 21 divided by 4, which is 5.25. L is not an integer. In this case, we are going to round up L to the next higher integer. So magiging 6th observation. So from the arranged data, the 6th observation is 22. Note that if we are going to interpret quartile, we need to multiply K by 25%. Therefore, we can say that 75% of the observations falls below 22. Now, we have this saying that goes, you can't compare apples and oranges. But with the use of statistics, it can be done to some extent. Suppose that a student scored 90 on a music test and 45 on an English exam. Direct comparison of raw scores is impossible, since the exams are not equivalent in terms of number of questions, value of each question, and so on. However, a comparison of a relative standard similar to both things can be made. And this comparison uses the mean and standard deviation, and it is now called the Z-score or the standard score. So the Z-score, which is the fourth measure of relative position, represents the number of standard deviations a data falls above or below the mean. A standard score or Z-score for our value is obtained by subtracting the mean from the value and then dividing the result by the standard deviation. And the symbol for the standard score is Z. So it is given by this formula. So the Z-score is equal to the value minus the mean divided by the standard deviation, or it is equivalent by this given notation in symbols for the formula. So let's consider examples. So for example, number 5, Aliyah has taken examination in reading and writing test. She scored 72 on the reading test with a mean of 65 and a standard deviation of 8. She received a 60 on a writing test that had a mean of 45 and a standard deviation of 12. In comparison to the other students, did Aliyah do better on the reading test or writing test? So to answer this given problem, we are going to compute for the Z-score for each test. So for our solution, so note that for the reading test, these are the given values. So Aliyah got a score of 72. The mean score is 65 and the standard deviation is 8. So solving for the Z-score, we have a Z-score of 0.875. While for the writing test, Aliyah got a score of 60. It has a mean score of 45 and a standard deviation of 12. Therefore, the Z-score is equal to 1.25. So comparing these two values, Aliyah got a higher Z-score in writing test. Thus, These Z-scores indicate that in comparison to his classmates, Aliyah scored better on the writing test than he did on the reading test, given that Aliyah got a higher Z-score in her writing test, which is 1.25, compared to the Z-score in her reading test, which is 0.875. Another example, an aptitude test has a mean of 220 and a standard deviation of 10. Solve for the Z-score if the test score is 218. So from this given problem, so we have the test score is equal to 218 with a mean of 220 and a standard deviation of 10. Solving for the Z-score, so just substitute the given values to the formula, we get a Z-score of negative 0.2. A negative value indicates that the score of the student is lower than the average. So since the Z-score for aptitude test is negative when the test score is 218, then we can say that the student is performing less than the average. And that would be all for the different measures of relative position. I hope you learned something from the video lecture. For queries and clarifications and questions regarding the topics discussed, feel free to contact me through my email address. Thank you so much for your time. Keep safe and God bless us all.